This video is designed to help you understand the relationship between logarithms and exponential functions, how you can quickly convert between the two, as well as how to simplify logarithms using the ideas of exponential functions. So the first thing we need to understand is why we need logarithms, how they're going to help us to solve equations. So if we have these exponential functions sitting before us, if we think about how equations work, we're just asking the question, 2 to what power? 2 to the x equals 8 for the equation up here in the left. 2 to the x equals 64 in the middle. So 2 to what power again equals 64. And the same thing goes for the other three equations. The base raised to that power will give you your answer on the right. So if we really think about it, 2 to the x needs to be equal to 2 to some other power. And if we can fill in that box thinking that, well, 2 to the third equals 8, if 2 to the x equals 2 to the third, and they have equal bases, and they're equal to each other, then x must be equal to 3. That's a simple way to solve that equation. Take a second, pause the video, and think about how to solve the other four equations here on the screen. Okay, hopefully you've had a chance to think about the equations. The basic idea again is just to think about those bases. 2 to what power gives you 64? And if we remember that 2 to the 6th is 64, then with equal bases equal to each other, x must be equal to 6. The same thing goes for 3 to the 4th is 81, so your answer is x equals 4. 5 to the 3rd is 125, so x equals 3. And if you count the zeros on the right here, 10 to the 6th is 1,000,000, therefore x must have equaled 6. That example works really, really well when you can have equal bases equal to each other. Now the trick comes in when you think about these two equations, 2 to the x equals 6 or 10 to the x equals 2,000. Remember that 2 to the 4th would be equal to 16, so that's much too large. 2 to the 3rd equals 8, still a little bit too large, and 2 squared equals 4, but now that's too small. So we've tried some of the low powers of 2, but we skipped right over 6. 6 should have fallen somewhere in between 4 and 8. So our power should fall somewhere in between 2 and 3. But the question is, where exactly is that? We could estimate it, or we can come up with a mathematical way to solve that equation. The same thing goes for 10 to the 3rd equals 1,000, and 10 to the 4th equals 10,000. But again, somewhere in between there is where 2,000 is going to fall. So we need to figure out somewhere between 3 and 4, as far as the power goes, should give us 2,000. And that's where logarithms come into play. A logarithm is a way to solve for that exponent. Logarithms and exponentials are basically inverses of one another. Much like addition cancels subtraction, multiplication cancels division, logarithms will cancel exponentials, and vice versa. So in order to solve those equations, and we will come back to those, we first need to know how to convert between logarithms and exponentials. So one way to do that is with what's called the swirl method. If you start with the base, and the base of a logarithm, log base 3, the base is written as a subscript. It's a smaller number to the lower right. If I start at that base and make an arrow curling around, I'm going to go to the other side of the equal sign and then swirl back to the number inside of the logarithm. And basically, if I'm going to switch this logarithm to an exponential, I'm going to start with base 3. What I curl over to on the other side of the equal sign will become my exponent. And what I end up pointing at inside the logarithm is what the exponential would have been equal to. And we realize that 3 to the 2nd power equals 9. The same thing happens if you want to convert from an exponential back to a logarithm. 1/2 is now your base, so we're going to convert that to a logarithm. Log base 1/2 of, if I swirl around to the other side of the equal sign, and then back up to the exponent, basically inside of the exponential function, log base 1/2 of 4 will be equal to that exponent. And remember that the logarithm ends up equal to the exponent, much like it did on the left, 3 to the second power, we were equal to 2. Well, over here, the logarithm is equal to negative 2, and it was 1/2 to the negative 2 power. Take a second, solve the 2 at the bottom. Try to convert the logarithm to an exponential and the exponential to a logarithm. Taking a look at our two equations, 5 to the first power equals 5. We started at the base, swirled to the other side, and we end up equal to the 5 that was inside the logarithm over here on the left. Well, I definitely agree with that statement, as 5 to the first power is 5. So log base 5 of 5, when you have an equal base to the number that's inside, will always end up equal to 1, because the basic idea is that base to the first power equals what's inside. If a log is going to equal 1, you must have equal numbers. The same thing goes if 19 to the 0 power always equals 1, anything to the 0 equals 1, well, log base 19 of 1 has to equal 0. So we just defined two very basic formulas for logarithms. The log base a number of that exact same number will always equal 1, and the log base anything of 1 will always equal 0, basically the reverse of the exponential rules. Well, let's go back real quick and look at the definitions again of logarithms. Logarithmic form is saying that the log base b of y can be equal to x. And if we do that swirl, we start with the base, that means that b to the x power equals y. So let's go ahead and solve the 2 up top here. Let's start with 2, and we'll make a curl past the equal sign and back around to the other side, saying that log base 2 of 6 equals x. And if I start on this side over here, base 10 past the 2000 back over to the x, log base 10 of 2000 also equals x. And now we can take out our calculators and we can find those two numbers. Log base 6, if we take our calculator out and type in control 10 to the power, oops, better get a calculator screen first here. If we say control 10 to the power, we can put in our base, and remember we want to type in log base 6. Make that log base 2. Sorry about that. Delete log base 2 of 6, and we can press enter. And also we wanted to do log base 10, control logarithm, log base 10 of 2000, and we'll get our answer there. And just like we thought before, 2.585 approximately falls in between 2 and 3, those two exponents we had over there on the left, and log base 10 of 2000 is 3.301, falling right in between 3 and 4, just like we thought on the right there. Well, once we know how to convert logarithms, we want to know a few of the basics. So again, how to type them into the calculator. A good lesson in that would be to try typing in log base 3 of 15. So back on our calculator, and I'll try to position so that we can see the controls here. Let's see if we can't position this so it's a little more visible. There we are. So that we can type in log, which again was right above the 10 to the power button on our TI Inspire calculator, base 3, so we're going to just type in a quick 3 of 15. Remember that there's always a logarithmic base, and the 15 is just what's inside the logarithm. Okay, often a confusing point is that people think that's 3 to the 15th power, and it's not. Remember, what we're really asking is 3 to what power? We're trying to find the power, would come back out equal to 15. And if we hit enter, 2.465 approximately, 2.465 will be our approximate solution. Now there are two other specific kinds of logarithms that will be very helpful for you. There are what are called the common log and a natural log. The natural log is log base e. As we use e often with exponential functions, we need a way to go backwards. So we made an entire function just to do that. And the natural log, you'll notice, is right above e to the power. So it's an easy relationship to remember. But if you want to find the natural log, log base e of 2000, you can just type in natural log of 2000. Again, another way to do that would have been saying log base e. So we can pick our e off our calculator here of 2000, and we should get the exact same answer. 7.601 if we round correctly. Now, in addition, there's also the common log. If ever you don't see a base on a logarithm, that's what's called a common log, log base 10. So on your calculator, again, that's if you took your common log, you'd say logarithm. If you just skip writing the base at all, and then we wanted to find the logarithm of 12, well, if you skip writing it, notice your calculator will even know to just put in a 10. A common log is a log base 10. So 1.079 would be saying that 10 to what power equals 12? Well, 10 to the first is just a little bit less than 12, so we needed something just a little bit greater than the first power. A couple other rules for logarithm we've kind of already looked at. Log base b of 1 will always come out to equal to 0. Log base b of b, if you have an equal base to what's inside, will always be 1. And a larger rule with that is that log base b of b to a power will always come out equal to the power. And if you do the swirl method, you can quickly prove that b raised to the x would have been equal to b to the x. So for the problems down here at the bottom, log base 3 of 1 we'll quickly know is always 0. Log base 5 of 5, again equal bases, mean we get equal to 1. And the natural log of e, or log base e of e to the 8th, just comes out equal to the power. So you'll get that power of 8. One of the types of problems you're going to see in your homework are problems like this, where you can hopefully try to convert what's inside of your logarithm into a power that we can easily cancel. Think about how log base 5 and 125, or log base 2 and 64, how they could relate. How does the 2 relate to the 64 and the 5 to the 125? If we think about it, 125 is really 5 to the 3rd power. And again, if log base 5 of 5 have equal bases, your answer will be your exponent. So if we can convert each one of these logarithms into having equal bases, saying that 2 to what power gives us 64, well, I can remove the 64 and call it 2 to the 6th power. And again, my answer then is 6. Base 2 of 2 is going to cancel away. Again, log base 2 is one entity, so it totally cancels. Log base 2 and 2, and leaves you with just the 6. It can get a little bit trickier when you have log base 25 of 5. Remember that we're not allowed to touch the base. The base is still 25. But if we think about 25 and 5, 5 is the square root of 25. And remember that square roots can be written as fractional exponents. So if log base 25 of 25 to the 1/2 is equivalent to our original statement, our answer then is just a half, as log base 25 of 25 cancels away. Remember that log base 6 of 1 will always be equal to 0. And remember that also if addition cancels subtraction and vice versa, well, if logarithms can cancel exponentials, log base 5 of 5, log base 5 cancels with 5 to a power, we can also do that backwards. Log base 7 inside of a 7 to the power, well, base 7, log base 7, they'll just cancel and give you what's inside. So that 7 cancels with log base 7, and you get just e, or what was inside. Base 10 of log base 10, remember that's a common log, and our answer is 4. I hope that helps you understand logarithms, and I hope it'll help you do your homework. Good luck.